Well, hello everyone. My name is Mete Atamel. I am a developer advocate at Google, based in London. First of all, thanks for being here. I know it's late in the afternoon. I like traveling out of London because usually the places I go, they have better weather, but not so much in Copenhagen. So I think we have pretty much the same kind of weather. But Copenhagen is nicer because it's smaller and you can walk everywhere, and I like that. And also NDC, I spoke, my last conference before the pandemic was at NDC in London in January 2020. So it's great to be back again into in-person conferences because I did many online conferences in the last 2 years, but it's not the same. So I'm very glad to be here. Feel free to ask me questions as we go along. We have enough time, so just stop and ask me if something is not clear or if you have something to add. Today's talk is about what I call serverless beyond functions. When we think about serverless, the first thing that comes to mind is probably AWS Lambda, right? Or Azure Functions. I guess it is a .NET crowd. But I think it's much more than that. I mean, it definitely started with functions, but over the years, in the last 4 or 5 years, it evolved to basically the de facto way of running code in the cloud. So what I want to do today is that I want to talk about the history of serverless, the phases that it went through. And as it went through these different phases, I want to highlight what we had, what we didn't have, and also get to today and look at what we have today, and hopefully show you along the way what kind of things you can do with serverless today, okay? The presentation is already on speaker deck. I will probably have time to do some demos later, and those will be on GitHub, and I'm going to share the links at the end of the presentation. So everything you see today, you'll have them if you need them later. All right, so serverless, I mean, I don't want to go through like a long description of what serverless is, but just to recap, there's basically, in my mind, 2 ways of thinking about serverless. The first way is the operational model, so how do you run your code? And when we say we are running something serverlessly, what we usually mean is that there's no infrastructure management. There's infrastructure, but you don't have to manage it yourself. It's someone else's problem. There's base level security, so you don't have to worry about like securing the ports or making sure that your network is secure. That kind of basic level security is there for you. And one of the most important things about serverless is that you pay for what you use, right? Because back in the day, when you had a virtual machine, whether someone was using that virtual machine or not, you still had to pay for that virtual machine per minute, per hour, whatever the payment model was. But with serverless, we kind of expect that you pay only when things are being used. And if it scales down to 0, you shouldn't be charged for it, basically. So that's the operational model of serverless. On the other hand, when you're designing serverless services, they're usually service-based. They're event-driven, so something triggers your function or your container, either HTTP or some kind of pops up kind of message. And they're usually stateless, because these serverless services, they need to scale up and down. And when you have state with it, then it makes things more complicated. Then you need to think about sticky sessions and things like that. Whereas when you externalize the state, then scaling becomes easier, right? So that's what we roughly mean by serverless when we talk about serverless. So of course, depending on who you talk to, you get slightly different definitions, but let's stick with this for now. Now, when you look at different phases of serverless, and this is my idea of how serverless evolved, you might disagree, but I think the first phase was serverless before it was called serverless. I think we've been doing serverless more than we can admit, actually. Then we had simple functions, what people think about serverless. They are basically functions. That's what first comes to our mind. Then we started having containers coming into serverless space, and then serverless becoming more mature, and I'll explain what I mean by this later. And finally, at this stage, we have serverless expanding and integrating with existing systems, okay? So pretty much everything is becoming like in this serverless model, and they're also integrating with your existing things that might not be serverless. So let's go through these phases, and let's see where we came from and where we are going, and I'll also try to show you some demos towards the end when we look at different parts of serverless. All right, so serverless before serverless. Anyone recognizes this logo? No? Yes? What is it? Yeah, something Google, yes. Yeah, well, yeah. I am biased, well, I have to admit, yeah. So since I work for Google, most of my examples are from Google, but hopefully it's not going to be like these are the Google services. I'm trying to get across the concepts rather than the services. But this is exactly, this is App Engine. Sorry, I don't have things to give you like the previous speaker, but thank you. So this is App Engine. It was launched in 2008. And the goal was to make it easy for developers to build, manage, and scale web applications. You would write Python. It initially started with Python, but later we added Java. And basically, you would write Python in a certain format, and you would deploy it, and you didn't have to do anything else. There was no servers to provision, no database, no networking, nothing. By default, it just worked. We didn't call this serverless. We called it fully managed App Engine because it was kind of managed for you. But in my mind, this was kind of serverless, right? Maybe the payment model wasn't quite serverless, but it was the beginnings of serverless. And this was back in 2008. So when we look at this initial pre-serverless phase, first, this phase kind of paved the way for serverless that will come later, but it was very limited, like in terms of languages and versions. You could only use Python and a subset of Python, actually. You couldn't do everything. And then later, we added Java, but again, it was a very limited version of Java. You could only do HTTP, so only web applications. Very limited ecosystem. So we told people, write your application here, deploy to Google, and everything will be okay. It would be, your services would run, but it wasn't comfortable for people, right? Like people wouldn't just leave their open source stuff and come to Google and say, okay, I'll just trust on Google that everything will just work, which is understandable. And people at the time, they were running virtual machines on-prem and telling those people, forget about all that investment and just deploy our app onto this fully managed app engine and just trust us was a big step. I don't think people were ready for that. And there was no middle ground. So there was like on-prem virtual machines and then fully managed services, but people kind of needed something in the middle to make that step. And I think the serverless kind of evolved to fill that gap in the middle. So that was before serverless, even though I think it was kind of serverless. Then in the next phase of serverless, we started having simple functions, and this started with AWS. So AWS came up with the term serverless, AWS Lambda in 2014, which was followed by Google Cloud Functions and Azure Functions in 2016. And the idea here is that you define your function, which is usually HTTP triggered with request and response, and then you send your response back, and then you just deploy your function, and all the underlying details of how is this function is deployed, where it's deployed, how it's scaled, all that kind of stuff is kind of abstracted away from you, right? So it's very easy. Just write your function, deploy, and things just work by default. Although you need to look at the details, right? This is nice in practice, being able to kind of just work on the function, but then you need to think about, okay, which programming language am I using, and is this supported in the serverless platform where I want to deploy? And then once let's say we're using C# here, well, great, Google Cloud supports 3.1, but we are already on 6.0, right? So what do I do now, right? So there's this table, and by the way, this table is probably out of date by now because I put this together a couple of months ago. But there is this table that you need to think about with the language and also the versions of the languages. Is it supported in this runtime where I want to deploy my function? Secondly, these functions, when they initially were introduced, they supported HTTP, so they were usually HTTP triggered. And at least on Google Cloud, we had some other triggers. For example, we had cloud storage trigger, where you save a file and it creates an event, and that event gets to your function. Or you can have pops-up triggers, or you can have a scheduled event, so a schedule triggers an event and goes to your function. So you had HTTP as the main trigger, and you also had this kind of HTTP-wrapped events, but they were very limited, just a handful events. And the execution model, time and resources were limited. For example, as I mentioned, everything was HTTP request-driven, so you had to do everything in the request thread. You couldn't do anything in the background, for example. The processing time is limited. So by default, you got 1 minute to do something. And I think maximum was initially 9 minutes. So you had to do things quickly. You couldn't do like batch processing, for example, if you had lots of data. And your memory and CPU was limited, 8 gigs and 2 CPU, virtual CPUs, right? So you couldn't take anything you have and hope that it will work. You had to actually check it out with the language and the version, and also the resources. Like, do you actually have enough resources in these serverless platforms? And again, like, most of my examples are from Google Cloud, but I'm sure on AWS and Azure, there's these kind of limits as well. And we had this problem called cold start as well. So there was this like concurrency, concurrency one, meaning when a request came in, we had to create a new function for each request. So what that meant is that, if your function took a little bit of time to get initialized, the users would have to wait for that. So they would see this latency in each and every request, and that wasn't a great user experience. And then once you started having these multiple functions, they're not monolithic applications anymore, right? So because in a monolith, let's say you're designing a web API, you can have the whole web API on a single kind of app. But once you are dealing with functions, typically you have one path to a function, right? So every path has to be handled by a separate function. Now, if you need to build a web API, you need to group these functions somehow. And actually on AWS, there was no way to have public functions, meaning like functions with public endpoints. So what you had to do was you had to deploy your function, then you had to use API gateway in AWS to make that function public. On Google Cloud, the cloud functions, by default, they were public if you wanted them to be. But again, you still needed some kind of API gateway to kind of group them together into some kind of an API because of this one function, one path, one function problem. So all cloud providers, they had some kind of API gateway or multiple of them usually to group them together. And that's all we had in terms of kind of grouping things together with serverless at this point. All right, so in this first phase of serverless, we had limited languages and versions, so you couldn't run all the languages you wanted. Limited triggers, mostly HTTP based. Limited resources, so you can't run all the workloads. No concurrency, like so one request to one function, which meant cold start problem if your function takes a little bit of time to start. And I didn't mention this, but also the local development was limited. So if you wanted to run a function locally, you had to kind of figure it out on your own. There wasn't that much local support, like how to run, say, cloud functions, for example, on Google Cloud Functions locally. You could, you had to deploy and see that it's working fully usually. And we had some grouping for HTTP functions, but there was no complicated orchestration. So you could group them together, but that was pretty much it. You couldn't do much else. All right, so in the second phase of serverless, we started seeing containers come into the picture in the serverless ecosystem. And containers, well, first of all, why we had containers is that containers give us a context where that we define. So if we have our application, we define what our application needs, what libraries it needs, and what environment it needs, like the port numbers and things like that, and we create a container out of that. And that context run exactly the same, whether I'm running it locally or whether I'm running it in the cloud. Because of that, we started having technologies like Kubernetes and Knative to run containers, because it made total sense to run containers in this consistent kind of environment. So for some time, I would say for a couple of years, we had these two separate worlds. We had the serverless world with the functions, which was really easy way of running code in the cloud that let you kind of iterate fast and not worry so much about the infrastructure. But then we also had this container world where you define the runtime, you use whatever the language you want, but it didn't run in a serverless way. So you had to, like when you were using containers, you had to actually worry about clusters, like Kubernetes clusters and virtual machines and how to schedule them, things like that. Kubernetes made it easier, but it wasn't as easy as serverless, right? So this lasted for a few years, but thankfully, we started having technologies like Cloud Run on Google, App Runner, or even AWS Lambda on AWS now runs containers, and on Azure container instances. So the whole point of these services is is to run containers as if they're serverless functions, so that you can create your container and not worry so much about how to schedule the container or where the container runs. And when you look at Cloud Run, for example, it's actually based on open source project called Knative, which is an open source project from CNCF that tries to make it easier to run containers on Kubernetes. But then there's a version called Cloud Run, which is a fully managed service that runs Knative API on Google Cloud. So with technologies like this, now we could define our runtime in containers, and we could also run them in a serverless way, where we don't have to worry about provisioning machines, we don't have to worry about auto-scaling, and all the things that we take granted in serverless. Of course, these containers, in containers you can run anything you want, but the containers that I'm talking about, there's a contract that you need to adhere to, right? This contract, for example, you need to listen on 000 on port variable, which usually defaults to 8080. It's an HTTP server, so we are still running HTTP servers that must start within 4 minutes, so it should be something that starts quickly. The request time started increasing. So in functions, for example, the request time, the time that you need to respond to was initially 1 minute, but now with containers, we increased that to 5 minutes, and it could be up to 60 minutes, which means that you can do more lightweight data processing kind of workloads. Still stateless, because you need to scale these containers, so it makes sense for them to be stateless. You still need to do everything in the request, so you can't do background threads still. The resources are increasing, so now we can have 4 virtual CPUs and 8 gigs, so it's better, although it's still limited. And concurrency increased from 1 to 80, and I'll talk more about this later. And also the ability to listen multiple paths. So in functions, as I mentioned before, you have one path, one function, whereas in containers, you basically have an HTTP server. That means you can have multiple paths that you can handle in a single container. So things are slightly getting better in the sense that we are having more resources, more time to process things, multiple paths, multiple concurrency, but there's still limits that you need to think about, right? It's not like limitless and you can run anything you want, however you want. And the concurrency is that, in Cloud Run, which is the container service, and Cloud Functions second generation, concurrency is 80, meaning 80 requests can be handled by a single function or a single container. And this does not eliminate cold start, because the first request that comes in, you still need to create the container, so you still have the cold start problem, but it makes it much more improved, because when the second request comes in, you don't have to pay for that penalty again, because it will probably go to the same container that's handling the first request, and because of that, you don't see cold start as much, right? So here, it's not like we got rid of the cold start problem, but it's much more improved because of this concurrency being more than one. And there are more options for local development. So since these are containers, you can run containers locally with Docker. You can use build packs, which is an open source project, to convert your code into containers. Then on Google, there's functions framework that lets you run your functions locally if you use this framework. There's emulators for services, like if you want to use data store or PubSub emulators, you can in your tests. And then on AWS, there's a project called Local Stack that lets you mock basically all the AWS services. So at this phase, we started seeing more support for mocking things so that we can run things locally, or we can use them in our tests, things like that. And I already mentioned this. Basically, we are getting more time, more resources, always on CPU for background processing. And I think the biggest thing at this phase was that we started seeing protocols outside HTTP. Well, not outside, but at least more richer protocols. For example, WebSockets, so that we can do real-time connectivity between clients and server. We started seeing server-side events in Cloud Run, and gRPC, which is a much more efficient encoding protocol compared to JSON. So you started doing this kind of stuff when you start using containers and Cloud Run. And we also started seeing basic orchestration. So if you wanted to do scheduled services, for example, you can use something called Cloud Scheduler on Google Cloud, where you define what the schedule is, and it will call not only your Cloud Run services, but any serverless service if you like. And on Azure, this is called Scheduler, on AWS on CloudWatch. And then there's something called Cloud Tasks, where you basically define a task, push it to a queue, and that task gets pushed to a service that you define. So these were kind of the beginnings of an orchestration. So if you want to control who calls your service in what way, you could at least do it in a time-based way, or you could do it in a task-based way at this phase, but it was still quite limited at this stage. All right, so at the end of this phase, we could run any language and version, because with containers, basically it's up to you to define your runtime, which is good. We still had limited triggers, so we are mostly HTTP based still. The execution model, time, and resources are increasing, but they're not limitless. Cold start is not a problem anymore for the most part, because we also introduced something called minimal instances, for example, on Cloud Run, which means if you set this, for example, to 1, it means you will always have 1 container running. So with that, you really don't run into cold start anymore. So this cold start problem kind of goes away with concurrency and minimal instances. You have options for local development, and you could do HTTP grouping with API gateway, but you could also have some basic orchestration with schedulers and tasks and other services where it lets you call your serverless services with some basic orchestration, but nothing complicated yet. All right, so now in this third phase, which I think is the phase that we are in right now, what we started seeing is the expansion of serverless and serverless becoming the de facto way of running things, and also serverless integrating with existing non-serverless things. So let's look at what I mean by this. Now, once you start having many services, especially serverless services, at some point, you need to decide how these services will cooperate, right? How are you going to get them kind of work together? Now, if they're HTTP-based, then you can use API gateway to kind of group them together into an API. So that's one way. But if they're not HTTP-based, or if it's like an event-driven kind of architecture, what you can do is that you can have your services deployed separately, and you can use events for them to communicate indirectly. So you have a message broker in the middle, or a service bus, whatever you want to call it. And the services, they just generate events as they work on things. And then the other services that are interested in that event, they would pick that event and just act on it, right? So service A will send an event. I mean, this diagram is a little bit wrong. It shows that events are being sent from service A to service B. It's actually not like that. It's more like there's an event bus in the middle, and service A, when it's finished, it will send an event, and then that event type is kind of registered with this service, so that service will pick that up and act on it, right? So there, it's indirect and it's async, right? It's not one-to-one like that. So this is one way. It's event-driven, or it's also called choreography. And it enables you to kind of have loosely coupled services. They're loosely coupled because services, they don't know about each other. All they care about is that, these are the events I'm interested in, and it will pick that event and act on it. But you don't really need to know, service B doesn't need to know about service A. And if you need to change any of these services, you can change them without having to worry about the rest of the services. All you need to worry about is the message types and message formats. So if you need to change anything about the messaging formats, then it can become a little bit more complicated. So this enables you to do loosely coupled services, but at the same time, once you start having a lot of services and a lot of event types, then it becomes a little bit difficult to monitor things, right? So in your system, if something goes wrong, what happened? Like, how do you figure it out? Like, which event wasn't triggered? Or maybe an event was triggered, but a service didn't process that event, right? So it becomes a little bit tricky to figure out when something doesn't work. Another way of getting services to cooperate is using an orchestrator. An orchestrator is an external service where you encode what should happen. So you encode the rules of your system. And then orchestrator makes the calls to the services in the order that you define. There are services like workflows, for example, on Google Cloud, where if you want to call the services in like service A, service B, service C, service D, it will make those calls on your behalf. And if something goes wrong, it will let you know that I made a call to service B in step 2, but that step failed. So you can easily see if things not work. Of course, there's pros and cons of each approach. I mean, event-driven systems, they're better for loosely coupled, easily extensible kind of architectures. Orchestration is better for where you want to group things together, but you don't want to put them in a monolith. Instead, you deploy them separately, but you kind of bring them together in a temporary way using an orchestration. And it also allows you to monitor your system easier, because when something doesn't work, the orchestrator will tell you that this service didn't work, basically. So when you look at choreography, the event-driven systems on Google Cloud, there's EventArc and PubSub as the services to do this, and on AWS and Azure as well. There's multiple services actually to do this kind of stuff. I think the challenge here is figuring out which service to use, right? Because in each cloud provider, there's actually multiple services for eventing. On Google Cloud, EventArc is the way to go because it's the easiest way to connect different things together. But sometimes it's not enough, and you need to actually do like lower level eventing with publishers and subscribers and topics and queues. For that, you could use PubSub. So the point here is that you don't need to write your own eventing system. There's already eventing systems out there on all cloud providers, but you need to pick the right one. So that requires that you actually look into these services and pick the right one. And then what EventArc enables you to do is that now all of a sudden, you have all these Google Cloud sources and also third-party sources outside Google Cloud that becomes available to your service. So your service, whether it's Cloud Run or Cloud Functions, can get triggered from multiple places. It's not only like HTTP calls or anything like that. It can be from multiple services, or it can be from external services like Datadog or some other third-party providers. So you are increasing your triggers basically from just a few services to tens or hundreds of services. Now, if you want to use orchestration approach, let's say you have this kind of a flowchart, and you want to encode this flowchart into an orchestration, and you want the orchestrator to make these calls for you. You can do that with workflows on Google Cloud. On AWS, there's step functions for this, which is more geared towards AWS ecosystem, meaning you can orchestrate the ecosystem services using step functions, but you cannot orchestrate external services, for example. On Azure, there's durable functions for orchestrating functions, but there's logic apps to orchestrate pretty much everything. So you can orchestrate services within Azure, but you can also include external services like any public HTTP service. Basically, you can include it in your logic app orchestration. And workflows, just to mention briefly, it allows you to orchestrate your code running on Google Cloud. It lets you orchestrate APIs on Google Cloud, and it also allows you to include external APIs in your orchestration. And maybe this is a good time to show you an example. So let's see how we can chain some services using an orchestrator. Let's see how that looks like. So here, what I want to do is that I want to have multiple services that are chained together. So it's just a single chain. But the point here is that these services, they run in different places. So some of them are functions on Google Cloud, some of them are external functions, and some of them are containers running on Google Cloud. So if you want to kind of combine this together into an orchestration, what you can do is first you deploy your services. So here I have a first service called random gen, which generates a random number. It's a Python. I think it's a Python function. The code is there if you want to take a look at it, but it's very simple. It just generates a random number. So I deploy that. Then I deploy a second function called multiply that takes two numbers and just multiplies them. Again, it's a Python function, so I deploy that as well. Then the third function, it's an external function from math.js. And what you can do with math.js is that you can call math.js with an expression. And here I'm using the log expression. So I give it a number, and it gives me the log of that number. So this is an external function. And then finally, I have a fourth function, which is a cloud run service, which runs a container. And this container takes the floor of a number, right? So given, let's say you give 6.8, it will just give you 6, basically. So if you want to put these together, what you need to do is first you need to you need to define your orchestration, and you can do that in YAML or JSON. And in this YAML, we define the steps of what should happen. So the first step, I call it random function step, and I'm making an HTTP call to this cloud function that I deployed. And this call will be made by workflows, and the result will be saved into this variable called random gen result. So it will make the call, and it will save the result. Then in the next step, I call the multiply function. Again, I'm making the call to the cloud function, but this time I'm doing an HTTP post, and I'm passing as the body the result from the previous step, so random gen result, and I get the body, and I get the random field from the body. So I'm parsing the result from the previous result, basically, and then I'm passing that as input to my second function. And once workflows make that call, then the result will be captured in multiply result. And the third one is a log function. Here we are making an HTTP GET call, and we are calling this external API math.js, and we are calling the log as an query expression. So this is just the HTTP GET with a query expression, and I'm passing the result from the previous step as well. And then finally, we make a call to the floor function, and here I'm calling a different URL. This is a Cloud Run URL. I am passing this authentication parameter because it's a private service, and I want to make sure that my workflows can call this private service. And with the input is the body of the result from the previous step as well. And the final result, it's the result of the floor. So in the end, we'll return the floor result as the result of the orchestration. So this is how you can kind of build your orchestration. I mean, this is a really easy example, but you can see how it helps you to kind of build these more complicated orchestrations. And just to show you that it works, let's see if I have here. I have service chaining. And then if you look at the source, one thing that you'll see is that first, well, the code I show you is here, but you also get a visualization. Here you can see that it's a chain of things. And then if I want to execute, there's an API, but we can also execute it from here. I'm not going to pass in any input. And then now the orchestration is running, and within a few seconds it should run, and then we should see this is the input, and the output is going to be the result of the whole chain and the floor. So the body is 4, meaning, well, you have to trust me that all the functions were called, but in the end, the floor returned 4, and I'm also returning the HTTP code and some headers. So that's the output. So this will give you a little bit of idea on what you can do with workflows and how easy it is to kind of bring all these services together. Now, once you have the basic orchestration, what I see happening is that I see people combining event-driven systems with orchestration, right? Because sometimes it makes sense to group things together, but once you have the grouping, it also makes sense to make that loosely coupled with other groupings, right? So in this case, for example, I want to build an image processing pipeline. And in this image processing pipeline, I want the user to save an image to a cloud storage bucket. And then I want a number of services to process that image. And then in the end, I'll save the processed image to an output bucket, right? So in this case, these services, I have 4 services. Filter function. This will filter the image, whether it's a safe image or not, using machine learning. And once it's filtered, we want to go to labeler. Labeler will use machine learning to extract the labels from the image, so figure out what the image is about, and save those labels. Then resizer will resize the image to a 400 to 400. And then finally, watermarker will take the resized image, and it will take the labels, and it will create a new image with the resized image and the labels on top of the image, right? So if you want to do something like this, Now, these filter, label, resizer, watermarker, they need to go in that order. You don't want to resize if you don't filter, right? Or you don't want to watermark if you don't have the labels. So you really need to call them in that order. And you probably want to deploy them in that order too. So that's why it kind of makes sense to put them in an orchestration rather than make them event-driven. Because if you make them event-driven, they will be loosely coupled, but at the same time, like you will lose that ordering, and you need to you still need to order them somehow with these events. So instead of that, it makes more sense to put them into an orchestration. But how do you trigger this orchestration? That should be loosely coupled. So when the user saves an image, that will trigger an event, and the event will kick off the orchestration. So I see this pattern of like event-driven plus orchestration all the time. And this is a quick example of that. And let's see, just to show you quickly like how you would set this up. Basically, again, it's the same as before. Like you would deploy your services. So you deploy your watermarker, resizer. They're all functions. Actually, in this case, they're .NET functions. Filter and yeah. So once you deploy all your functions, then you need to create your workflow. And let's just quickly look at the workflow. And actually, maybe we can look at it from here because we'll see a visualization. You go image processing. If you look at source, so you see that this, hopefully it's big enough. But you see that it will receive an event. So this will be the cloud storage event. Then we define the steps where we log the event. Then from the event, we extract the file information. So where is this event coming from, which bucket and which file. Then we have a filter step where we call the filter function with the file information. Then the filter will have a response. Then we check the response. Here we are checking the response to see, you can do like a conditional switch statement. So here I'm doing a condition and I'm checking the filter response, body safe, true. So if it's true, then I conclude that it's safe. And I go to the next step, which is label. But if it's not safe, then I end my orchestration, right? So I do that kind of checks. Then we call the labeler function. Then we call the resizer function. Then finally, in the watermark step, we call the watermarker with the file from resize function and also the labels from the label function. So we pass those as inputs. And in the end, the output will be the response from each service. And then if you look at the visualization, again, you get this nice visualization where you see how things are supposed to work. So for example, if you look at filter, we call the filter, we log it, and we check it if it's safe. If it's not safe, then we can see that the orchestration ends. But if it's safe, then it will continue, right? And to actually see that this is working, if I go to one of my buckets, I think it should be this one, but we'll see. So let's upload a picture. Let's say I upload this picture. Now, once we upload it, this will trigger an event. And if we look at workflows, image processing, we see that there's an execution already. So that triggered the execution. And if we click here, we see that there's the input. So the input is the event that has the bucket information, the data from the event. And then we see the output already, the HTTP codes from each service, in this case 200. So it seemed like everything worked. And if just to verify that everything worked, if I go back to output bucket, then I think this was the picture we uploaded. So you can see that this picture, it resized it, so that's why it's kind of skewed. But then it also extracted some labels, and we use these top three labels to kind of overlay on top of the image. So this choreography and orchestration kind of working together is a common pattern I see. Another pattern I see is that combining serverless with serverful. So as I mentioned, the serverless functions or containers, they have limitations. They have time limitations. and they have resource limitations. Let's say you want to run a really long-running process that needs to run for days or weeks, or if you need to run something that requires a lot of resources, at that point, you really don't have a choice other than running on a virtual machine, right? So you define a virtual machine with the resources that you need, and then you can run it there. But then who's going to manage that virtual machine? So one pattern that you can use is that you can use the serverless orchestration to kind of set up your virtual machine and run that virtual machine and get the result and then delete that virtual machine. So in this example, I won't show here, but in this example, I show how to have a long-running container provision on a virtual machine, run a virtual machine, get the result, and then delete the virtual machine. In this way, you are using the power of servers, but then you're not really dealing with the overhead of servers. You just use it as long as you need it, and once you have the result, you can shut it down and just display the result. So that's another pattern as well. And finally, so far we've been talking about HTTP-based services, so everything is triggered by HTTP. But sometimes you have just a piece of code that you want to run that's not really HTTP-based. It just needs to run with certain inputs, right? There's now something called Cloud Run Jobs, which is something that's released recently, that enables you to run non-HTTP containers. So these are containers where you just run some code, and it runs as long as it needs, and then once it's done, it will just shut down, right? I call these run to completion containers. This enables you to do more things like batch and data processing kind of workloads, but without having to deal with virtual machines. So we are trying to make it easy so that you don't have to deal with virtual machines as much as you can. So with Cloud Run Jobs, you can do that. You can just say, okay, here's my container, just run it, and when you have the result, when it's finished, we'll just finish and return the result. So if you want to look, there's also an example of this here. So when we look at the state of serverless today, you can use any language and version. That's not a problem anymore. You have rich triggers, so you're not limited just by HTTP or just by cloud services. Like there's third-party things that can trigger your serverless. So you need to figure out how to connect these services to your serverless services, but they're there, so you don't have to worry so much about how I do it. It's just a matter of finding out. The execution model time and resources are more, but they're still limited, but you can always combine it with serverless, with servers, and with that, you don't really have any limits anymore. So whatever you can run on a server, you can still do that, but you can use serverless orchestration to orchestrate it. Cold start is not a big problem anymore. You can do local development, and you can do grouping, but you can also do rich orchestration with things like workflows and logic apps. So anything you want to orchestrate and put together, you can do that with serverless today. So I think the point, and also we didn't talk about all these services. I'm not going to talk about it, because one thing that's kind of unfortunate is that I see a lot of people spending time kind of building services in a serverless way, but then in the backend they use like a SQL database that's not serverless, and it's not even managed, right? So they're kind of managing that. So that's kind of a tragedy, because you spend all this time making this serverless, but then in the end you still need to deal with something in the backend. But thankfully there's choice on on every cloud on NoSQL databases or SQL databases or caches, so that there are things that you can use that are not fully serverless, but at least they're kind of managed. That makes it easier on the data side as well. And also there are services like SendGrid to send emails, or Twilio to make calls or send SMS. So always try to look for these things instead of trying to start a VM and do things on your own, because they really help to keep things like as server-free as possible. But just keep them in mind. I guess that's what I mean here. So the point of the talk is that basically, in my opinion, serverless is now the default way of running code in the cloud. So when you're building something, check it out, see if you can do it without servers. But then if you cannot, you can always use virtual machines. But even those, try to see how you can automate them using these serverless technologies. Because in the end, I think the more we automate and the more we get away from servers, the easier it is for us to maintain our systems. I think that's all I have for my talk. Thanks very much for being here this late. And yeah, we have time for questions, so I'll be happy to take some questions. Thank you. Yeah. Yeah, so I will repeat the question for the camera as well. So I mentioned earlier that it's difficult to monitor serverless things, but you didn't tell us how to do it, basically, how to monitor them. Well, the context was that in event-driven systems, it is difficult to monitor when something fails. When something fails, it's not so easy to know where it failed. I mean, there are certain things you can do. For example, every event has an ID. So every event can have an ID, and you can try to trace that ID. Or maybe you can have like a correlation ID where you can combine multiple events into a single correlation and try to see where the correlation broke. But I don't think there's also there's the saga pattern. For example, when something fails, if you can detect it, you can try to compensate it using this saga pattern. So there are certain things that you can try to do, but admittedly, it's not easy. Like I don't think there's a solution where I can say, okay, in event-driven systems, do this, and you'll figure everything out. My solution is to use orchestration. Actually, in one of my other talks, I go through an application that was written in event-driven way, and then we rewrote it using orchestration, using workflows. And one of the main takeaways was that it was much easier to figure out when something went wrong. So if you can go to an orchestration kind of way, I would suggest that for monitoring. But for eventing, I don't think there's like an easy solution to kind of monitor what went wrong. I mean, all I do is that I try to kind of put some IDs and trace them, and then check the logs, eventually see if I see something in the logs, which is not a great answer. Any other questions? Yes. Yeah. I think the next step is that we won't use the term serverless, because it's like, I think it's one of those terms that became kind of overloaded with everything. So by default, most of the services will be like fully managed, so you don't have to think about servers. And the payment model as well will be serverless in the sense that if you use it, you pay. If you don't use it, you don't pay. So that will be the default. And once that's the default for everything, then I think we'll just talk about services like we used to do, like service-oriented architectures. So these things, I think at the end of the day, that's what serverless is, like service-oriented architecture with some additional things like payment models and stuff like that. So that will be the default, and I think we'll just call them services. At least that's my opinion. I don't know if someone agrees or not. Yeah. Right. Yeah, so the question is like things like minimal instances, for example, do you have to deal with that yourself today, but is it going to be more kind of handled automatically for you in a way, right? Yeah, I mean, the reason why, for example, the reason why you need to think about minimal instances today is that if you set minimal, so right now, if you don't set minimal instances, it's 0, meaning your service, if no one uses it, you don't pay anything, right? But as soon as you set it to 1, then you will be paying for that one container running at all times. So that's why we give you that option, because you're the one paying, right? So we can't just say, oh, we'll set it to 1 and you pay anyway. No, that wouldn't be nice. But I think the problem will go away in the sense that as they do more optimizations on how things start, then maybe things will start so fast that it won't even be an issue anymore. So I think in that sense, it will probably go away at some point. But as of today, the functions, at least cloud functions, it does take some time, some milliseconds for it to start. And depending on also on your code as well, like how you wrote the code, how you initialize things, it will take some time. So that's why it's a problem. But maybe the platform will improve to the point that we can kind of initialize things in the background and then get things up and running really quickly. I do expect that to happen, but I don't know exactly how or what would be the form of that. Yes. Yeah. So let me see. Your question is, so why is orchestration as a separate concept? Well, so you mean like instead of this, why don't I have a service that calls other services? Is that the question? Yeah, you could have that. I mean, you could have a service. You could write your own orchestrator in that sense that you could have a service that calls other services. And actually, the durable functions in Azure is kind of like that. That's what it tries to do. But I think it is limited because, yeah, I mean, you can have a service call other services, but the orchestrator does more than that. It calls the services. If something goes wrong, you can define the retry policies. So how you want to retry if a service is down? You want to retry 3 times or 5 times? Do you want to do exponential backup kind of way? Or you want to just keep doing it every certain seconds? So the orchestrator has all that logic to do that. It has other concepts like if a service returns a certain error code, you want to call, let's say service A returned HTTP 500, you want to call service D afterwards. So that logic can be part of your orchestrator instead of having it in your code. So I guess my answer is that an orchestrator it's not just calling services, it's calling services and handling errors and retries and branching and checks, all that kind of stuff. In my mind, it belongs to an orchestrator rather than just a service, because that service, like, who's going to maintain that service? Who's going to scale it? What if the service goes down? At least, I don't know logic apps, but at least on workflows, it's highly resilient, highly scalable kind of system. So I'd rather have workflows do that than me trying to do it in my own services. Yeah. Right. Yeah, that's a good point. The workflows, for example, you need to write things in YAML or JSON, and YAML is not designed for anything complicated. But so sometimes I am trying to think like, okay, like how do I do this in YAML? And it's not a great experience. But we are thinking of creating like a language, or maybe use some mainstream language to define these orchestrations, or at least define it and then get it compiled to YAML so people don't have to deal with YAML. So it will get better. This is kind of like a starting point for orchestrators, I think. Yep. Any other questions? Okay then. Well, thanks very much. Enjoy the rest of the conference.